Hello everyone, welcome to STEM with Chantel.
I'm Chantel, and this is Ty.
My name is Colin Drake. I'm a principal at JRA Architects, a firm in Louisville and Lexington, Kentucky. We're a company of about 35 people working in the realm of planning, architecture, interior design, and have been in business for actually this year 75 years. Me personally, I'm one of the principals of the firm and focus almost exclusively on design projects, which include schools, libraries, civic buildings for cities. I dabble in working on schools and occasionally the interesting, out of the ordinary project that comes in the office. Sure, so every project takes a little bit different order, but in general, typically a client will come to us with a problem they're trying to solve. Oftentimes it is they have a need for more space than they have currently, or they're ready to move from location to location. And so that basically kicks off the first stage of design, which is the planning and programming stage. At this point, we're not talking about bricks and mortar, we're really talking about space and experience and needs that the client has. Like, why are they coming to us for this project? So we do a lot of listening in that phase. We do a lot of question asking, trying to get to the root of the problem we're trying to solve for our clients. That tends to last perhaps a month to 2 months, where you're really getting to the root of each individual space that they might need, how those spaces might function, how many people might be in individual space, how that business or that school or that library operates Monday through Friday. Does it operate a little differently on weekends or on holidays? Just trying to understand how the business works and how people that are in that facility will move around day to day and do whatever it is they do in those buildings. From there, once we get that kind of baseline established for what the project needs to be, essentially that is setting the ground rules, setting up all the parameters that then, kind of like a checklist, we're able to, through the course of design, actually go through and take, we caught everything on this list, and we actually identified perhaps a few more problems along the way that we needed to solve. But that really gives us a roadmap for where we go once we really start designing the building. The next stage is schematic design. That's where we're taking their inspiration, perhaps buildings that they've enjoyed, or perhaps if it's a renovation project, the building that's already there, and really getting to the root of what does this thing look like, how is it laid out, how are these spaces related to one another. So it begins a lot of times with colorful diagrams. There's actually one kind of behind me here on the wall, which is for a library that I did here in Louisville, where it's really just kind of getting big picture. This is next to this. These people will be here. Those people over there, and making sure that all the big idea pieces are generally in the locations where they would want to be. And then toward the end of schematic design is when we get into what the building with the big grand ideas, inspiration. A lot of times we'll look at precedent projects, things that we've seen anywhere around the world really are either beautiful, functional, or a little bit of both, that help drive the aspirations of our clients and hopefully for us as well. From that, after schematic design, we move into a phase typically called design development. That's where we get into more of the nuts and bolts of how it works. So this is, what are all the outlets? Does so-and-so need a phone? What do these light fixtures look like? What is that material on the wall? What colors are we talking about? What's flooring, the walls, the ceilings? How acoustically absorbent are the ceilings? How well do all the different systems perform and talk to one another? Is this going to be a really aggressively sustainable building in which we need to have solar panels on the roof, or we need to have rainwater collection to be able to flush our toilets? This is all technology that's readily available now, which is really exciting about the profession today, is we can basically make buildings that run without being connected to the power grid or having to use municipal water, which is just amazing that we've gotten this far, and that this technology is really readily available even to the most traditional project. From there, we move into construction documents. This is where we're, down on our, it used to be our drafting boards, and now it's just our computer screens, just figuring it all out, figuring out how all the different detail components go together to actually turn these ideas that are on paper into a legitimate building. So we're working with our engineers, structural engineers, civil engineers to figure out grading of the site, structural to figure out how the building stands up and making sure beams and columns all work together in concert with the rest of the building, and that things aren't bumping into each other. You don't want a duct running right through the middle of a beam. And so what's great about a lot of new programs we have built to us, those help us visualize how those bits and pieces fit together and really avoid any conflicts later on when we're trying to build the building. That's usually the longest phase. That for a perhaps a 20 to 30,000 square foot building might take anywhere from 3 to 5 months. So that's definitely the biggest part of the chore for us, is to complete those construction documents. But those basically are the instructions that we give to the contractor, to the construction manager, to build the building. And so it's really important for those to be thorough and well considered, and make sure that we've essentially tied up as many loose ends as we possibly can. From there, there's a pretty short-term phase known as bidding. That's where we're getting the drawings out to interested contractors and getting pricing back from them. This is typically also the time where we go and get permits pulled from the different agencies, either state or local agencies, to make sure that we're following all the codes that are in place to allow the building to be safe and habitable and function the way people expect a contemporary building to function. After, typically that takes 3 to 5 weeks. After that is when construction starts, and that role for the architect typically is to be on site, to observe construction, to make sure it's meeting the intent of the drawings, because a lot of times you won't see a lot of drawings on the site. There is a lot of communication that happens between the contractors and just a ton of people that they're trying to manage. So there's always a certain amount of back and forth that has to happen between us and the contractors to help interpret what might be a 40, 70, 100-page set of paper into something that might be tens of thousands of square feet of actual building. There's no way in the world we could literally draw every corner of a project. So inevitably, we're trying to solve problems that arise during construction. And then, we function as the owner's eyes and ears on site. So we're expected to approve the applications for payment that come in from the contractors every month. We're expected to be the mediator. If the contractor and the owner get in a dispute, we are typically the first line of conflict resolution, to be kind of an independent party that tries to resolve conflicts between the owner and the contractor, which typically don't happen, but when it does, we're there to serve that purpose. And then ultimately, we're there to certify both to the owner and to the state or whatever jurisdictions oversee the project that it has met the intent of the project, it's safe for occupancy, and ultimately sign off on the building being occupied by people when it's all finished. What's great about especially greenfield sites, which are properties that have never been built on before, is you don't have to deal with the unexpected. Typically, the greatest source of unexpected cost on a project is what's hidden below the surface of the ground. Obviously, anything above ground you can see, anything below ground you can't. So you can imagine on a building site where there have been buildings built in the past, even if it's an empty site, if you knew there were houses that were built on a site that now wants to be a college dormitory, let's say, you may run into the foundations of those old houses or the sewers from those old houses, that sort of thing. Well, adding on to an existing building is that next step that's even more complicated. Well, now you're dealing with the structure of the existing building. You need to make sure that you're complementing that structure so that if there's an earthquake, they're going to, basically oscillate in concert with one another and not tear each other apart. You need to make sure that you've got enough space overhead, because if the building happened to be, say, 100 years old, they didn't have electricity or plumbing or modern heating and cooling. So all of a sudden, the space between floors might not be enough to get modern ductwork and plumbing pipes and that into buildings. So there are inevitably limitations that an existing structure will put on you, and you need to be able to play by the rules that that existing structure set up. And then there's just the reality of the materials. You know, there may be brick that you want to use that hasn't been produced in 70 or 80 years. You know, being able to marry new materials with the old materials to be as complementary as possible is always a challenge that comes with doing renovation projects. Absolutely. If anything, that's probably the most notable thing that differentiates just a normal building from a piece of architecture is the character and the aesthetics of the building. We try to pride ourselves on being experts at understanding what is attractive and also what is functional. And so when you're working with an architect, the aim is to create a building that is hopefully more than just the rooms and the walls that surround it. If you did need architects, everything would just end up being a metal shed out on a field, which for some purposes is perfectly reasonable. But if it's a municipal project or, say, a courthouse, you don't just want any old building. You need a building that has a certain character that is expressed to the public so that when the public's looking back at that building, they understand what they're building. And that's hopefully, in all cases, what an architect's bringing to that process is getting the character and charisma, I guess, that the building wants to show off to the public and its users. We just finished the country's first LEED Platinum, which is a rating system that's used to basically measure the sustainability of a particular building project. Our first LEED Platinum manufacturing facility in the entire United States near Lexington, Kentucky. We're super proud of that. I've also spent the past 10 years working on 3 regional libraries for Louisville, where we basically had the same program for each of the 3 buildings, but each one of them ended up being a truly unique finished product because of the surroundings and the community that they serve. One happened to be on a suburban lot and had a huge amount of stormwater on the site, so we created this stormwater basin with a bridge across it. The next was in the middle of a vast forest, so we were able to basically carve the building into the trees, and the building is surrounded by all these mature 80-foot tall trees. And the third one was on a public park, and we were able to actually open up the entire side of the building to the park, so the library literally spills out into the landscape. So just by seeing those 3 side by side really tells a pretty good story of how much of an impact architecture can have, because ultimately they were the exact same program, and yet those 3 buildings are very different than one another. This was a bit of a improvisational project that emerged one evening with a friend on a driveway during the beginnings of the COVID lockdown last year. And she and I were really excited to get out of our yards, get out of our houses, and do something that might actually engage our families, engage our friends that we couldn't be around. And so we went and did a little guerrilla landscaping on a local middle school playing field, where we just used some regular old push mowers and mowed a 2-acre maze into this middle school field, and found over those couple days that it was there that our friends, our family, grandparents and grandkids, and kids that were as old as 2 up to their grandparents getting dragged around through these mazes, really engaged with this in a way that was just unbelievably impactful to us. And this was about the same time that we were having all the just sad events surrounding all of the just social unrest that happened last spring. And so it seemed like a perfect opportunity to use something as simple as just some mown grass to hopefully bring people together. So we've been reaching out to public facilities, schools, parks, libraries across the state and even beyond Kentucky, to offer our services just as a pro bono project. This is purely a spare time activity for us that we get to scratch the itch of designing these mazes and incorporating the trees or any other landscape features that are happening on a particular site. But more importantly, being able to engage with these communities in a way that shows them that there really is that much more to go and experience out in landscapes that otherwise were perhaps mundane or perhaps forgotten, and really capitalize on those leftover spaces to hopefully bring people together. The last 50 years have seen buildings go from being energy hogs. You would see buildings that only had single panes of glass to keep heat and cold in and out. And in those 50 years, the focus on making buildings perform well, to use less energy, to be more comfortable, to be places where people could be as productive as possible, really has come into focus in a very clear way, especially in the last 20 years, where you have energy codes that are released by the federal government and then the states adopt them, that are really pushing to make buildings be a good steward of public investment and of just people's pocketbooks. There's things always seem to get more expensive as time goes on, and so we ultimately have this responsibility to make our buildings, which end up costing more these days, pay themselves back by using less energy and ultimately costing less to operate over time. So that's probably the biggest change. Ultimately, I don't know that most people would even notice the difference. You're looking through a pane of glass, it still is clear, you can still see through it, but all of a sudden now that piece of glass is 10, 20, 50 times more efficient than it was several years ago, and that's what's great, is we're not necessarily completely changing how buildings look or function, but the way that they use energy and the way that they kind of give back to their owners and users is pretty profound in this past 50 years. Well, I can say just in the 20 years that I've been in the profession, the advent of new technology has been pretty spectacular, to where we're now doing 3D visualization, being able to walk through our buildings in virtual reality in a way that basically eliminates a lot of the unknowns that would come with traditional blueprints, drawing things on flat sheets of paper and hoping that they look good in real life when they're built in 3D. We can jump that learning curve in a big way now, but in these next 50 years, there will very soon probably be a time where we can put on a set of glasses and go out into the field and actually be able to visualize. If you're just seeing the building structure, all of a sudden visualize all those finishes on top of that building structure, to be able to prognosticate where problems might emerge and be able to avoid any confusion or any challenges that might come up in the field. So the advent of augmented reality, virtual reality, the really interesting technology that's emerging in terms of AI, that it's now allowing technology to create iterations of design, so you can give parameters to a program and have it spit out design solutions. It doesn't necessarily take our jobs away completely yet, but it is really interesting to see now that we don't necessarily have to generate all these ideas ourselves. You can plug in the parameters, set the rules, and then let, much like a calculator does for us, you learn how to do the equations. But ultimately, once you understand the concepts, let the machine do the extra work, so that you get to make decisions more quickly and know that those decisions are vetted in a way that will give you the best solution. Because ultimately, that's what this is all about. It's giving clients the best solution to solve their problem.
Thanks for watching. If you would like to see more STEM with Chantel videos, check out this playlist. If you want to know when JCPL puts out more content, click the subscribe button and the notification bell.